Well, I'm going to produce a series of video lectures on the applications of Newton's laws, the Newton laws of motion. I should say that Newton laws of motion is the heart of classical physics, classical mechanics. All the motions within the classical framework are governed by Newton laws. Whenever you talk of a law in physics, then that means authority. So Newton laws of motion are the authority of all the motions that is within the classical framework. Now, when I talk of classical framework, that means I'm emphasizing on the fact that physics is not just classical physics. There is, of course, relativistic physics. There is, of course, quantum physics. There is, of course, quantum electrodynamics, the particle physics, and so on and so on. But if we confine our attention mainly to the IIT JEE, the NEET exams, and the pre-university exams, then, of course, the classical physics is the maximum which is within your program. If you look at your physics program in the classical physics, you will notice there are so many motions, there are so many chapters on motion, they are devoted to motions. For example, translatory motion, the motion in a straight line, the parabolic motion, the motion of a projectile, circular motion, well, general circular motion, uniform circular motion, there is a rotation, there is rolling motion, there is oscillatory motion, there is planetary motion in the chapter of gravitation. Well, rolling motion and oscillatory, and then we switch on to the simple harmonic motion and so on. So all these motions that I am talking of within the classical framework, they are governed by the Newton laws. I will produce a basic lecture on the Newton laws in its importance and its application. I'll explain to you how the second law and the third law and so on, but that would be a basic lecture. Here, I'm going to, in this particular video lecture, I'm going to explain to you how you can work out, apply the Newton laws of motion to work out a problem of connected bodies. I'll take a simple case because slowly we'll graduate to very difficult problems on the application of Newton laws. So all those students who are going to follow this series of the application of Newton laws are going to gain tremendously. In this particular video lecture, I'm taking two blocks, block 1, block 2, and they are connected together. They lie on a rough surface, and purposely I'm taking both the blocks of different nature on the same surface. Therefore, there would be a different coefficient of frictions. And then we'll apply force on block 1 as well as on block 2, and we'll investigate its motion. And the major interest will be, number 1, to find out the contact force, the friction force on each block, and the acceleration. I may not follow all these things in sequence, but when I analyze this, you will know how to handle problems of connected bodies. Mind you, I have already emphasized the fact that I'll be producing a series of video lectures on the applications of Newton laws, and this will give you a very thorough grounding and understanding of the application of the Newton laws. I can't say all that in this particular. Maybe I'll have to produce at least 15 to 20 video lectures on the application of Newton laws, and then you can really feel that you are a very, very smart student of physics. So let us see. Let me explain to you the situation. The situation is this. There are two blocks, block 1, the blue, and the block 2, the red. They lie on the green, the rough surface. The coefficient of frictions, well, here mu S1 is 0.5, mu K1 is 0.4 on the blue box, block 1, and on the red box, mu S2 is 0.3, and this is mu K2, and the mu K2 is 0.2. All right. I apply a force 30 Newton parallel to x-axis in this direction, and I apply a force of 12 Newton in this direction. So this is to the right and this is to the left. Purposely I am doing that. And what is my purpose? My purpose is to find, number one, the acceleration of the system. The system is block 1, block 2. Add together makes the system. Number 2, how much is the friction force acting on each block? Is the friction static? Is the friction kinetic? We'll see. And of course, number 3, the contact force between the blocks. The contact force between the blocks, which I will denote by capital F dash or capital F prime. Let's start now. Remember, whenever you are tackling a problem on the application of Newton laws, in case of connected bodies, no, single body is okay. Maybe I will not even make a video on the single body. So if your connected body like this is block 1 and block 2 are connected together, then first and the foremost thing, you apply the Newton law of motion, that is law number 2, on the whole system, taking the whole system as one body. And of course, as you know, in the free body diagram, we take the body as a particle. So first of all, I'll apply the Newton laws on the whole system together as one body, and the whole system as one body will be 6 kg body, 6 kg body. All right. To apply the Newton laws, we'll have to make use of the friction forces. So it is good, it's a good habit first to make your friction bank. I use the word friction bank for each block. Okay, mu S1, so Fs1m, mind you, it's only the maximum static friction and the kinetic friction which you can find by the law of friction. Static friction you cannot find by the law of friction because that is a variable self-adjusting force. There can be a whole video just on making you understand friction. Okay, I will do that as one basic video just on making you understand the friction. But here, well, I will of course assume that you have done the friction at your elementary level. So Fs1m and Fk1, these two can be found by the laws of friction. Of course, Fs1m will be mu S1 multiplied by N1. So here you are. So Fs1m is mu S1 N1. So 5 upon 10 multiplied by N1, that will be 40, gives you 20 Newton. Keep it. And now static friction can vary between 0 to 20 N. It can be equal, it can be 0, and it can also be 20. So 0 to equal, less. Mind you this. So Fs1 can be equal or less 0 to 20 N. This is the friction bank. Fk1 will be mu K1 into N1. So 4 by 10 N1, that is 16 Newton. Keep it. Fs2m, 3 by 10, 0.3. So 3 by 10 into N2. So 3 by 10 into 20, 6 Newton. So Fs2 can vary between 0 to 6N. And Fk2, 2 by 10. Look at this. 2 by 10 multiplied by 20, 4N. Our friction bank, we keep it in the store. Keep it in the reserve. We'll use it in our problem when we are analyzing this problem. Okay, now let us see. First of all, I apply the Newton's second law on the whole system. That is 1 plus 2 as a system, that is 6 kg system. And I find capital F. Now remember, for me, the capital F is RTF. RTF, resultant tracting force. The net force responsible for traction of the system. Now look at the figure. 30 Newton to the right, 12 Newton to the left. So what is the net? The net is, of course, if you 30 minus 12, that is 18 Newton to the right. This is the resultant tracting force, the force that is responsible for the traction of the system. Now this is 18 Newton and to the right. Keep it. Now let's see what is the max. Now first of all, we have to see, will the system move or not? And for that, I'll have to take the maximum opposing force to the tracting force. The maximum opposing force to the tracting force, that is 18 Newton. How do I get the maximum opposing force? That will of course will be Fs1m plus Fs2m. Fs1m plus Fs2m. I find that it comes out to be 26 Newton. Wow, 26 Newton. Traction, 18 Newton. Come on, 18 Newton is not able to overcome the opposition. Therefore, system will not move. System will not move means what? Acceleration is 0. One answer is already there. Acceleration is 0 means what? On both the blocks, static friction is acting. On both the blocks, static friction is acting. On 1 as well as 2, Fs1 and Fs2 are acting. Now, Fs1 and Fs2, we cannot find by the law of friction. So now we'll have to analyze the problem, and we also have to find the contact force between the bodies. That is what I'm denoting by capital F dash by drawing the free body diagram on one of the bodies. So I cut the two bodies, separate them and do the free body diagram on any one body. Say I'm doing it on one. I'll do it on both. I'll do it on both for you. So FBD on the block 1. Okay, here you are. So 4 kg, weight 40 Newton down. Surface will push it up. So that is, of course, N1. That is here, N1. So surface, push it up vertically. So N1. 30 Newton here. 30 Newton is here. 30 Newton is here. Forget this. This I don't know. This I don't know right now. This we'll have to calculate. This is not, we'll have to calculate this. But I've shown you because I've given you the results here. So 30 Newton is here. Fs1 is 20 Newton. So what happens now? This is 30. This is 40. This is N1. Let us say we don't know this. Let us say we don't know this. Let us say we don't know this. I should not have put it here. So let it. 30 Newton is acting here. F dash is acting here. But the acceleration is 0. What are the other forces acting? Fs1 and F dash. And the system does not move. That means Fs1 plus F dash should counter 30. So this plus this should be 30. Now what do? I'm stuck. There are two variables. Oh, so what I do? First of all, I'll take help of the static friction. And the maximum static friction the block 1 has is 20. Although 20 is not able to counter 30, so I'll lift up the entire 20 from here. So this Fs1, I will take 20. The whole of friction, come on. I need 30 rupees. In my bank, I have got 20 rupees only. So I'll take the whole 20 rupees and 10 rupees I'll ask my friend. I'll have to borrow from my friend. And the friend here is F dash. So 20 Newton, I make use of my own bank. Here you are. And still it doesn't counter 30 Newton. So F dash will be 10 Newton. So there you are. So the friction on the first block is static and it is 20 Newton. Now let's come on the block 2. Let's come on the block 2, the free body diagram. Weight down, and N2, the normal contact surface gives it a normal push upward. Now F dash action reaction pair. If this is 10, now this I already know is 10. This, let me not show you first. So this is 10 Newton. 12 Newton is already acting here. Look at the diagram. So 12 Newton is here. And acceleration 2 also is 0 because the system is not moving. So this means 12 has to be counterbalanced. 10 to the right, I am already having the contact force between the blocks. The other has to come from friction. And look at the interesting thing. The friction will now act to the right. On this block, it will act to the right. Now that's the beauty of friction. It always opposes the relative motion of the point of contact. Students who think friction opposes motion have a misconcept in their mind. Friction opposes the relative motion of point of contact. So this is 12 Newton here. It is already acting. Contact force is 10 Newton. System does not move. That means the balance, I am taking the friction, that will be 2 Newton. And it will be to the right. So I get the final answer to this particular problem. Acceleration is 0. The friction on both the blocks static. It is 20 Newton to the left on block 1, 2 Newton to the right on block 2, and of course the contact force between the blocks, that is F dash, is 10 Newton. On the block 1 it is to the left, and on the block 2 it is to the right. It is to the right. Action reaction pair. This is action reaction pair. Now I just do one simple thing in this problem and the whole scene will change. What I do now is that instead of this 30, I make it 40. I make it 40. The same problem, everything remains same, but only this force instead of 30, with this change that we have made 40 Newton here and 12 Newton here, so the resultant tracting force becomes 28 Newton. The maximum opposing force Fs1m plus Fs2m was 26 Newton. Now 28 is more than 26. This means the whole system will slide. There will be an acceleration. We have to calculate that acceleration. And on both the blocks, kinetic friction will act. Fk1 on first block and Fk2 on second block. And both kinetic frictions will act to the left. So here we are. First of all, let us find A. So for the system, 6 total mass 6 into A, 6 into A should be resultant tracting, that is 28, because it is 28 resultant tracting, 40 minus 12 minus Fk1 minus Fk2, that is 28 minus 16 minus 4, that is 8. Therefore A is equal to 4 by 3 meter per second square. So the system will slide with 4 by 3 meter per second square to the right. Now let's do, to find the contact force between the blocks, let's do the free body diagram on the block number 1. 4 kg. Gravity force 40 Newton down, N1 up. N1 up. 40 Newton is acting here, F dash, the contact force is acting to the left, and the kinetic friction 16 Newton, look at that, 16 Newton is acting. I apply the Newton's second law, so 4 into 4 by 3, m into A is 40 minus F dash minus 16. I solve it out, F dash comes out to be 56 by 3 Newton. 56 by 3 Newton. Okay, the problem has been solved, but let us check whether we are right. So let's draw the FBD on the block number 2 and see whether we have done everything correct. So in this case, I'll assume the F dash as 56 by 3, and let us say we don't know A2. We know A2. A2 should come out to be 4 by 3. But if A2 is unknown, let us do it free body diagram on the block 2. So on the block 2, gravity force 20 Newton down, N2 up, 56 by 3. This is F dash. To the right, 12 Newton is already acting. To the left, friction is 4 Newton. And let us find A2 just for fun, as if we don't know A2. We find A2, we apply the Newton's second law. So 2 mass into acceleration, 2 into A2 is 56 by 3 minus 12 minus 4. I solve this, I get A2 as 4 by 3 meter per second square. This means everything is correct. So I hope you have enjoyed this video. Thank you very much for watching. Thanks again, and we'll carry on with our series of videos on application of Newton's laws of motion. Thank you once again.
If you like the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.